The law of conservation of mass. Mass can neither be created nor destroyed in a chemical reaction. That means in a chemical reaction, mass is not created nor is it destroyed. Let us take an example to explain this. If I have calcium carbonate, and if you heat calcium carbonate, a chemical reaction takes place and calcium carbonate decomposes into calcium oxide plus carbon dioxide. Now it was found that if you take 100 grams of calcium carbonate, you will get 56 grams of calcium oxide and 44 grams of carbon dioxide. Now the reactants in this is calcium carbonate, and the mass of calcium carbonate equal to 100 grams. And the products, we have two products, calcium oxide and carbon dioxide. The mass of calcium oxide we saw is 56 gram and of carbon dioxide is 44 gram, and if you add up this you get 100 gram. So the mass of the product is 100 gram and the mass of the reactant is also 100 grams. So here mass is neither created nor destroyed. So we have mass of a reactant equal to mass of product. So in a chemical reaction, mass is neither created nor destroyed, which means mass of reactants is equal to total mass of products. For the next, sodium carbonate reacts with ethanoic acid to form sodium ethanoate, carbon dioxide and water. So let's write this out. So we have sodium carbonate. This sodium carbonate reacts with ethanoic acid and then it forms the reactants, forms the product. The product is sodium ethanoate plus carbon dioxide and water. So these are the reactants. And here we have the products. Let us find out what is the mass of the reactants. So to find out the reactants, mass of reactants, the reactants are, one is sodium carbonate, and if you look up and see, they said 5.3 grams of sodium carbonate. So this is 5.3 gram reacted with 6 gram of ethanoic acid. So ethanoic acid is 6 gram to form 8.2 gram of sodium ethanoate. So now we are getting on to the products. If you see, we have three products. One is sodium ethanoate, then we have carbon dioxide and water. Let us find the weight of each, mass of each. So sodium ethanoate is 8.2 gram, carbon dioxide is 2.2 gram, and water is 0.9 grams. If you add up this, we will get here 13.3 gram. So this is mass of products. And the mass of reactants, and we add up the mass of reactants, here too we get 11.3 gram. So this is mass of reactants. So what have we noticed here? We have noticed that mass of products equal to mass of reactants, or mass of reactants equal to mass of products. So this verifies law of conservation of mass. Mass is neither created nor destroyed in a chemical reaction. Calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. Let's write that. So we have calcium carbonate is the reactant. It decomposes to form calcium oxide, which is a product, plus carbon dioxide. Let's put up the values. 10 grams of calcium carbonate, so we put 10 gram here, is decomposed completely to form 5.6 grams of calcium oxide. Calculate the mass of carbon dioxide formed. So we do not know the mass of carbon dioxide, so we will put X gram. So the reactant, this is the reactant, and here we have the product. The mass of reactant is calcium carbonate, and we know the mass is 10 gram. And the products, we have two products. One is calcium oxide, which is 5.6 gram, and other one is carbon dioxide, which is X grams. So the total mass of products is 5.6 plus X. And according to the law of conservation of mass, by law of conservation of mass, we know mass of reactant equal to mass of product. Now the mass of reactant we take as 10 equal to mass of product. Mass of product is 5.6 plus X. So we go ahead and solve this. We'll get X, which is mass of carbon dioxide, is 10 minus 5.6, and that is 4.4 gram equal to X. So mass of carbon dioxide equal to 4.4 gram. So the amount of carbon dioxide produced is 4.4 gram. If 100 grams of calcium carbonate in the form of marble or chalk are decomposed completely, then 56 grams of calcium oxide and 44 gram of carbon dioxide are obtained. So we have calcium carbonate is decomposed. We get two products, that is calcium oxide plus carbon dioxide. So here is the reactant. Calcium carbonate, they said, was 100 grams, so this is 100 gram. Calcium oxide was 56 grams. So here 56, and carbon dioxide 44. These are the reactants. Calcium carbonate is the reactant. So let us find out the mass of the reactants. Calcium carbonate, mass 100 gram. And these are the products. And we have two products. One is calcium oxide, which is 56 gram, and carbon dioxide, which is 44 gram. When you add up, you get 100 gram. So here we have seen that mass of the reactant equal to mass of the product. So mass of reactant equal to mass of product, and this verifies law of conservation of mass. Which says in a chemical reaction, matter is neither created nor destroyed. Copper sulfate reacts with sodium hydroxide to form a blue precipitate of copper hydroxide and sodium sulfate. Let's write that. So we have copper sulfate. They said reacts with sodium hydroxide to give copper hydroxide which is a precipitate plus sodium sulfate. Put in the weight. They said in the experiment 15.95 of copper sulfate, so this is 15.95 gram, react with 8 gram of sodium hydroxide to give 9.75 gram of copper hydroxide, so 9.75, and 14.2 gram of sodium sulfate, so 14.2 gram. I will see the reactants. Here are the reactants. We have two reactants. One is copper sulfate, which is equal to 15.95 gram, and sodium hydroxide, which is equal to 8.00 gram. Now the reactants, we have done with the reactants. Now the products. These are the products. Two products: copper hydroxide, which is 9.75, and sodium sulfate, (14.20). So we'll now calculate the total mass of reactants. If you add them, you get 23.95 gram. And the mass of products, you add this up, you get 23.95. And here, if you've noticed, the mass of reactants equal to mass of products. And this verifies law of conservation of mass. Which says matter can neither be created nor destroyed in a chemical reaction.